Hi everyone, this is Dr. Brahmayya, Associate Professor, Department of SNH, MLR Institute of Technology, Hyderabad. Today, I am going to talk about estimation of hardness of water by EDTA method. Overview. Introduction to the complexometric titration, basic principle, experimental procedure. So, introduction. Hardness in water is due to the presence of dissolved salts of calcium, magnesium, salt. It is unfit for drinking, bathing, washing, and it also forms scales in boilers. Hence, it is necessary to estimate the amount of hardness producing substances present in a given water sample. So, hardness causing salts, what are those? Magnesium, bicarbonates, calcium, bicarbonates, and calcium sulfate, magnesium sulfate. These kind of salts always form the hardness in the water. So, we have to remove these salts at any cost while we are using the water. So, for this, before using the water, we have to go for the checking of all these salts, how much concentration is present in the given water sample. So, this will be estimated by EDTA method. What is EDTA? Ethylene diamine tetraestic acid. So, this is the compound which always used for the complexometric titration to find out the hardness of the water, how much hardness is present in the water. So, hardness of the water is determined by titrating with a standard solution of ethylene diamine tetraestic acid. So, this is the ethylene diamine tetraestic acid. So, how to make it this estimation we can see. So, these are the salts Mg2 plus ions and Ca2 plus ions. We have to remove or we have to estimate this one. So, by this method, we have to estimate how much concentration of these salts are present in the water. So, in alkaline conditions, pH greater than 9, it forms stable complexes in the alkaline earth metal ions. So, what are the alkaline earth metal ions? Of course, and these are the second group elements of the periodic table. These are the alkaline earth metals. So, EDTA can combine with the metal ions in 1:1 ratio to form a chelate structure. So, how that chelate structure will be formed, I can show you here. Generally, this is the EDTA structure. This is the EDTA structure. It is a salt. EDTA salt. It is a disodium salt of EDTA. So, generally, this is the complex. How it forms, we can see here. Right. So, M metal ion or M2 plus ions. This will form complex with the given EDTA. This is the complex formation. It's a stable complex. It's a stable complex. So, by forming this complex, we can estimate the concentration of the hardness causing salts, how much present in the water. So, basic principle, the total hardness of the water is estimated by titrating the water sample against EDTA using erichrome black tea EBT indicator. So, EBT indicator. So, it is also a complex compound. It is also forming a unstable complex with the hardness causing salts. What is the EBT structure is? EDTA structure is like this. Generally, the serichrome black tea forms a complex with the metal ions with the calcium and magnesium. Like you can see here, OH thrice. Like this complex, it will be formed. So it's a weak complex, which is not strong. So initially in the titration, in the burette, we will take in the EDTA. In the beaker, we will take the standard water or given sample water that will be mixed with ammonical buffer 2 to 4 drops and the EBT indicator. We can also add EBT indicator to find out the end point of the reaction. So initially hard water which are having a Ca2 plus ions, Mg2 plus ions, and with the EBT under the basic conditions buffer solution 9 to 10 pH, wine red color solution will be formed. Unstable complex due to the EBT, weak complex formation, and then it will be titrated. It will be titrated with EDTA. Then it can form a colorless stable complex, but EBT will be removed as a steel blue color. Steel blue color. Here, you can check here. This is EBT. After adding the EBT, the solution will be like this, wine red color. And then after EDTA complex formation, the EBT will be removed as a steel blue color. This is the end point of the reaction. End point of the reaction. This is the basic principle actually we have to follow in the estimation of the hardness of the water by EDTA complex. So since there are two complexes are formed, this is a complexometric titration. This is the meaning of the complexometric titration because of these two complexes. So initially EBT forms a weak EBT, Ca2 plus Mg2 plus, as we discussed just now, wine red 2 colored complex with a Ca2 plus Mg2 plus ions present in the hard water. On addition of EDTA solution, the Ca2 plus Mg2 plus ions preferably forms a stable EDTA complex and leaving the EBT indicator in a solution with the steel blue color in the presence of the ammonical buffer solution NH4OH and NH4Cl. pH maintenance up to 9 to 10. Thus the end point is the change of the color from the wine red to blue. So this is the reaction what actually happens in the complexometric titration. So experimental procedure, see here, this is the experimental procedure. Preparation of the standard hard water 0.01 molar. So dissolve 1.0 grams of the CaCO3 in minimum amount of dilute HCl and make up to 1000 ml in a standard flask with a distilled water. So how much? 1 gram of the CaCO3 will be taken to make the standard hard water in the laboratory, and then small amount of dilute HCl will be added and make up to 1000 ml in a standard flask with a distilled water. So here, if you check here, before adding the calcium carbonate, true. After adding the calcium carbonate. So standardization of the EDTA. Add 4 grams of the disodium salt of EDTA to 1.0 liter of distilled water. Fill the 50 ml burette with EDTA solution. This is the standardization of the EDTA solution. So pipette out 20 ml of standard hard water into a conical flask. To it, add 2 ml of ammonical buffer, 4 drops of EBT indicator. So, as we discussed earlier, wine red to steel blue color will be formed in the final product, in the final end point of the reaction. So, let the volume of the EDTA consumed by standard hard water by A ml. Repeat the titration to get concurrent values. So, what actually is going on? We have to make the standard hard water with 1 gram of CaCO3 in a minimum amount of dilute HCl and make the up to 1000 ml in a standard flask with a distilled water. Then standardization of the EDTA solution. So the molarity of the hard water M1V1 is equal to M2V2. So M1 molarity of the standard hard water. How much it is? 0.01. How? This 1 gram of CaCO3 has been taken. Molecular weight of the calcium carbonate 100. Taken amount 1 gram into 1000 by VML. It is 1000 ml. So it will be vanished. 1 by 100 is equal to 0.01 molarity. So this is the 0.01 molar of the standard hard water. To know the concentration of EDTA, we must know some known solution. So that is the known solution is molarity of the standard hard water is known solution 0.01 molar. So volume of the standard hard water is 20 ml. So in the beaker, molarity of the EDTA solution we are going to find out. Volume of EDTA solution, burette reading, it is like AML. For example, we can take it as a AML. How much it is consumed, we don't know. After titration, we can come to know the consumption of the EDTA in the given standard hard water solution. So M2 is equal to M1V1 by V2. 0.01 molar of the M1 and the how much M1? It is 0.01 and then 20 ml. This is the volume. And AML is how much consumed of the EDTA solution in the titration. It's AML. So now you will get M2. The molarity of the EDTA solution. Estimation of total hardness of the water. Now, estimation of total hardness of the water. Since we already standardized the EDTA solution, now we are going to find out the total hardness of the given water sample. It's very clear that initially we have taken the hard water, it is prepared in the lab with 0.01 molar known concentration. But now we are going to check about the sample water which was given by others or which will be in the available laboratory as a tap water. So we have to check it. So keep it out 20 ml of sample water into a conical flask. To it add 2 to 3 drops of the ammonical buffer solution and 4 drops of EBT. Titrate with EDTA solution till the wine red color of the solution changes to blue color. So let the volume of the EDTA consumed by sample water be BML. Repeat the titration for the concurrent values. It implies that we have to repeat the titration for at least 2 to 3 times, minimum 3 times. So the same readings will become once you are going to do the titration. Then we have to stop the reaction and we have to go for the further calculations. So molarity of the hard water M2V2 is equal to M3V3. M2 molarity of the EDTA solution from step 2. V2 volume of the EDTA solution, burette reading BML. M3 molarity of the standard hard water, how much? V3 volume of the standard hard water. So M3 is equal to M2V2 by V3. M2 we already know from the step 2. B we already know this volume molarity of the standard hard water. We have to know this one. It is already known. V3 is the volume of the standard hard water 20 ml. So we are going to find out the molarity of the given sample. total hardness of the water is equal to x moles into 10 power 5 to convert into ppm. X moles into calcium carbonate molecular weight 100 into 1 liter 1000, it is 100. Overall it is x ppm. So estimation of the permanent hardness of the water. So boil 100 ml of water in a beaker till it reduces to 20 ml. Boiling removes the temporary hardness. It implies that bicarbonates will be removed from the given water by boiling. That is removal of the temporary hardness. Cool and filter into a 100 ml standard flask. Wash the precipitate with distilled water. Keep it out 20 ml of the water sample into a conical flask and add 2 ml of the buff solution, 4 drops of the EDTA. Again, the same titration, it will be repeated again. Titrate with EDTA solution until wine solution changes to blue color. So let the volume of the EDTA consumed with the boiled water be, it is CML. Repeat the titration for the concurrent values. Same titration, we have to go for the 3 times for the concurrent readings. This is the procedure. We have to move on. So to find out the permanent hardness, what we need to do it, we have to boil the water. Then the temporary hardness will be removed. For that sample, we are going to find out the concentration with the EDTA titration. For what purpose? To find out the permanent hardness of the water, because it is already removed the temporary hardness causing salts, calcium bicarbonates and magnesium bicarbonates. So the permanent hardness will be M2V2 is equal to M4V4. From step 2, we are taking these step 2 values. It is repeated. By these values, we are going to find out the unknown things. So M2, molarity of the EDTA solution from step 2. V2, volume of the EDTA solution, V rate reading, CML. EDTA consumed, how much? We have to find out from the titration. M4, molarity of the standard hard water. V4, volume of the standard hard water, 20 ml. So M4 is equal to M2V2 by V4, M2 into CML by 20 ml. So V4 how much? It is a 20 ml. So now it is Y moles. For example, it is Y moles. The permanent hardness of the water is equal to Y moles into 10 power 5. So 100 of CaCO3 multiplied into 1000. It is in a volume. So total 10 power 5. Y moles into 100 into 1000. Overall Y ppm. Concentration is Y ppr. So now we got the permanent hardness of the water. We already found that total hardness of the water and permanent hardness of the water. It is now very easy to find out the temporary hardness. So temporary hardness is equal to total hardness minus permanent hardness. Now total hardness M3 into 100 into 1000 minus permanent hardness M4 into 100 into 1000 people. This is the way how to find out our hardness causing salts concentration in the given water sample. Now in summary, it concludes that the presentation covers the introduction of the complex symmetric titration method to find out the total hardness of the given hard water sample. Experimental procedure of the EDTA titration for the standard hard water and the sample water. Finally, this lecture covers that how to find out the temporary and permanent and the total hardness of the water by using the EDTA complex symmetric titration method. Thank you.